let's make a test node. Why not? A class that is test node. The test node is basically from node base, and we can do this, copy paste, Control C, Control V, yeah, and the test node now, instead of a float, it's the test node. Oh god, gosh, not you. Delete and namespace test node. Okay, so the constructor, it will have only one output, but instead of this we will have 3 outputs. Okay, and here we will have a private a private vector tree, and we call it vect. Okay, and in initialize we say output equals to nothing. Okay, why not? Output 0, output 1, output 2, and we say vect equals to vector3.0, and now we say vect.x, vect.y, and vect.z. Okay, and we want this guy inside our update node. So public override our update node. Where are you? Okay, and we say that. So XYZ in 3 outputs. Now here we will say, instead of this, we say vector equals to vector tree field, and we say vector node value. Okay, and instead of this we say vector. Okay, now inside my work view I just added to the context menu, and inside enums, of course. So we have a vector tree, and that should be comma. Okay, inside work view, inside our context, we add one more, 7, and this is vector 3, and for 7, Control C, Control V, please reformat it, 7, and this is vector 3. Okay, so if I come back, I will delete this float. I will have a vector 3 node, and it didn't show up. And it's not added actually. Nodes, math, vector 3. Why are you not showing up? Because I don't have a case inside node details. God damn it. No details. So coming down, then we have the add. Yeah, that was the reason. Add it, shift tab, that. So if it is a vector 3, this is the test node, and we say vector 3 and vector 3. Okay, so coming back, now we should be able to make a vector 3, and my outputs are totally wrong now. But let's try something. Bam. And you see that if I change it, for example, to 30, this guy gets 30 plus 20. I add another add node, and I will just add the x and y here. Okay, so I will say 1 and 2. So this guy gets 3. And if I add another node, I can add 3 with the result of here, 80, so it becomes 83. Okay, now the only problem is why my outputs are showing mumbo jumbo. Good thing I tested. Coming to node base. So let's double check my node base. Close all documents, node base. When I'm drawing the outputs, new vector 2, I multiplied by, there we go. Bam. Crazy stuff. And for inputs, I had the same error. I fixed it there. Yeah. So if I come back, these should be correct now. There we go. Okay. So we simply added a vector 3 node. Now the question is vector 3 being serialized? Because I have doubts about this guy. And let's call it vector 3 node. Better. Thank you. And because if you come to vector 3, hit Control B so that it gets decompiled. You see that vector 3 class, it's a structure actually, okay? It's not serializable. At least it's not marked serializable. And there is nothing there to show that it's serializable, okay? You don't see anything like serializable stuff there. So, now tons of stuff, but none of them are serializable. So I have doubts. Let's check it. The easiest way to check a serialization is to hit play and change the values. And look at here. I'm highlighting it here, but then it's dragging the active. Okay, so 20. And if I stop it, it stays as 20. I get the value here, I get the value there, and it's 20. So when you play and stop, serialization and deserialization happen. So you are sure now that it's serialized properly. So is that hard to add more nodes? Well, not. Guess what? I will add a class for vector 2. Okay? And that Control C, Control V, yeah, it's a vector 2. Oh, got vector 2 node, sorry. So, vector 2 node, and this is a vector 2. Vector 2 has 2 outputs, so we don't have Z, we don't have Z, and it has a vector 2 field. Okay? And I'll have a vector 2 node. Just I need to go back, add these guys here. So vector 2, come to toolbars, add another case. Actually, look at here. Okay, so this is new, yeah, vector 2, that was why. God, resharper. So vector 2, And why are you not happy? It's vector 2 for 7, vector 3 for 8, and this is vector 2, Control C, Control V, and this is a vector 3. And this is case 8. So inside node utils, we want case for vector 2. Boom. Vector 2, vector 2, vector 2 node. And we are golden. You say no? Say no. When, I'm not showing it there. Inside work view, I forgot that I have, well, it should show up. Let it compile again. Oh, okay. Node base, so we have an error in node base because apparently, tons of places that I'm using vector 2. There we go. So node, math, vector 2. And we have a vector 2. And we can add 2 nodes, for example. A float. Connected from here, connected from here, here, here. Another add, here, here. This float node will be, I don't know, 1000. This guy will be 1000 by 2000. And this guy becomes 2000. This guy becomes blah. This guy becomes 4000. So vector 2 is working. And you can easily add vector 4 and quaternion if you want to, okay? So, yeah. The only thing I'm not happy if I'm dragging this guy and coming here, I'm moving my node. So I'll take a look at that. I think there should be possibility to, I don't know, check if we are clicking here, set a flag, and then check if that flag is on. Then don't move stuff, but that's only redundant stuff now. So we have our node graph, guys. Everything is working. We added a vector 2 for demonstration, a vector 3 for demonstration, and we moved the values out of the node into the outputs themselves, and because of that, now we have everything working. 20 and 20? 50. Thank you. Just so that I know I'm using different values. Yep, and it's working. So one more node that I want to add is a multiply node. So because sorry, a divide node, because it has a condition. Divide node, and it has a base. It inherits from node base. Thank you. Well, I don't have anything to do with you, so close. close, and I keep just this, Control C, Control V, that, and it's node, divide node. So it gets 2 inputs and 1 output. So inputs.add node input and node input. So it, in a sense, it's like add node. We don't have any evict. We say the output equals to 0. Now in update node, we say update.value equals to 0 first. Then we say if inputs of 1 does not equal to 0, okay? Then we say outputs 0 dot value equals to inputs of 0 divided by inputs of 1, okay? And dot value. Sorry. Come to the add node. This is how we are getting these guys. So Control C, Control V. If that is not equals to that, then input 0. Inputs 0. No, inputs 1. Okay. So if the inputs 1, parent outputs of this guy's connected ID is not 0, then we want that part, basically. Dot value, and this is input 0. Divided by the second value. Okay. So if the second value is not 0, because if it's 0, then we will get division by 0. If it's not 0, then of course do the division and show the result. Else we already set the result to 0. So let's add it to our, not pop-up, not editor, enums. And after add, we will have a divide. In node utilities and in workview. So after the add, I will add a divide with index of 7, 8, 9. So it will become 8, 8 and 9, and then we have case 7 here, and 7, and this is divide. Okay, and for divide I can go now into node utilities and say, well, we can add it anywhere else, but it's good to stay consistent. Divide. Divide. Node. Divide. And divide. So coming back, I will create a float, because right off the bat, the float will have the value of 0. Then I will add it. Oh, I don't see it yet. Did I have any errors? Yeah. Divide is not that. Okay. Outputs of 0 dot value. And we don't need actually this. We need this. And we call it result for whatever reason. Plus outputs of 0 dot value. There we go. And that is gone. So I have a float. Now I should be able to add a divide. Okay. And I will hook this guy as 4000. You see the result is 0 because this node is not input. We connect it. The result is still 0. But as soon as I, for example, point 2, this guy gets a result. Or divide by 10, for example. This guy gets a result. As soon as I break the connection here, the result will become 0. Okay? And it didn't break the connection here. So, did I found a bug? Break connection, it resets. It's not resetting the parent if I'm clicking on the child. So, if the object is input, break input connections. Okay, here. The parent node dot outputs index input dot connected output ID dot input ID equals to -1 and dot child node or whatever, what else we have is occupied equals to false, and finally the child node equals to null. Dot child node equals to null. There we go. So now if I connect this guy to this, if I break connection here, it resets that guy. Okay? Now it's working. So yeah, it's working now. So wait. It's setting this guy now. Okay, when I'm finalizing the guy, I'm forgetting something. Or I'm doing something dumb. Yeah, see? I'm doing the outputs on the same node. That was the part. Control C. Control V. And I was thinking that I didn't need these guys. Okay, so let's see. I break the connection, it resets. I set the connection, Reset the connection, and it's still doing this. Why? Oh, because I need to reset the nodes. Okay. So delete this guy, yes. Create a test node, test graph, add a float, add, move that float, add another float, and an add node, then another add node, and a float node. Connect this guy, reconnect this guy, and it's losing its stuff. So it's in finalizing. Where is that code? So we are setting it again yet on ourself. So input dot parent node dot that. Okay. Let's make sure it's working now. Yeah, there we go. Now it's fixed. So if I break the connection, it breaks the connection. If I break the connection, it breaks the connection. If I have a connection from here, I connect it from here to here. Come on, now it's broken again. Let's delete these guys. Because when you are constructing these type of, oh, hey, delete, you, delete, yes, create, test. Is that the case for every node that is, no, okay, no, okay, for whatever reason. Come on. So I hate this when we are creating the node. At the end that we set it, we say current graph. We don't have the graph. Oh yeah, graph dot selected node equals to node to the current node, and current node dot is selected equals to true. Before that we say if graph had dot selected node does not equal to null. We want to say graph dot selected node dot is selected equals to false. So the moment we create a node, we put it as a selected node. I hate that because it's sometimes hard. So we create, it gets selected. So I should be able to move it. Anyway, add the connection, add the connection, add the connection, and connect. We break this connection. We reconnect it. We break this connection. We reconnect it, and it's not connected now. So when I'm breaking the connection on input, I'm not able to connect it. Break input connections. Input that parent node equals null. Am I forgetting something here? I think so. Dot. No. That outputs of input dot connected. No. Oh, here we go. I found it. I'm setting the ID before setting it to null. Although, no, it should work. Okay, input dot connected output ID equals -1. Yeah, I totally forgot to reset those guys. So input dot, we are resetting the parent node is occupied. Well, I'm doing it. Okay, so let's do that at the end. There. I forgot to reset the connected output ID to -1. Did that fix it? So, of course, I can't. Oh, now I can't delete this guy. Okay, maybe that was the reason. Test, create, and create 2 float nodes, an add node, break the connection. Now it's working. So can I delete this guy now? Delete, delete, yes. So I forgot to set the the ID of the connection out to be 0. So an add node, just so that we make sure, break, reconnect, break, break, break. Yeah, everything's working now. Okay, 2 hours video divided at least to 3 videos, I hope, unposted it. The last thing remaining is that when I'm clearing the graph, you may not notice it, but take a look. We are keeping the data. So even when I'm deleting the node, so if I add a node, I'm adding another node. If I'm deleting it, the numbers didn't change. So, and what was that null reference? Test, create. Oh, we have errors. Float, add, connect, connect, add, connect, break connection, no errors, break connection, no errors, break connection, no errors. So if I delete, 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 and add, well, what was that error? Okay, whatever. And add. Okay, whatever. The only thing that is happening is that we are not really overwriting our asset there. So, first of all, we go back into node utilities because both of them are happening there. When we are clearing the graph, before we reset the list, we say if current, if, no, what was that? Yeah. I will cast it to say node graph equals to that. So if graph does not equal to null, then we want to do stuff. The very first thing that we want to do, and Control X, at the end of everything we say graph dot nodes equals to that. but now we say if graph.nodes does not equal to null and graph.nodes.any. So if you have anything in the list, we say for each inside graph.nodes, okay, var node, we want to say asset database dot remove do we have delete? No, I don't want that. Remove asset okay, none of this. After this we say asset database dot save assets and asset database dot refresh. So that's for clearing the graph. Deleting the node, where are you? Inside the graph itself. After we remove the node, we want to save asset database and refresh the asset database. Hopefully that was the only case. Okay, so we clear this guy. We add a test, whatever. We add a node. We clear the list, yes, and it's not removed. Huh. We add a node and we delete it and it's not removed. Well, this is bad. When we are creating the node, we have the option to say add object. Well, what do we have in asset database? Asset database dot. Open asset. Remove asset bundle, unused, remove array name, set labels, start asset editing. And we don't have anything to do with remove objects from asset database. Okay, the solution is this. Before doing anything, we say for each inside our graph.nodes or node, we should say object dot destroy immediate the node, comma, and allow destroy assets, yes, true, and then save the asset and refresh. Okay, and inside node base, when we are deleting this guy, where was it? No, in graph node graph. Okay, so before removing, we say object, not that, object in Unity dot, and why are you not showing here now? Check dot. Well, copy paste is your friend. Boom. Yes, and delete. I think I ruined something in, yeah, there. Okay. Destroy immediate and then save and refresh. Okay. And actually, now that I think about it, well, let's try it first. So we clear this guy, we create a test graph, and I want to keep an eye on my graphs. So add, delete, and it's deleted. Okay, add, another one, clear, yes, and it's deleted. There we go. So that was the last part. You would think that this guy would sit inside as a database anyway, but you know that we are using asset database here. Okay, so of course this class should go inside our using Unity editor. So close it here. When you are using Unity editor, we are saying do that. Okay, so anywhere that you are using asset database, you need to do that. And actually in runtime, we don't want to let people delete nodes from graphs. That's a good thing. And also, I don't see deselecting it outside of this class that is inside Unity editor, so why not use it there? Now, that's okay. So I'm just now checking if I'm using Unity editor anywhere outside of the editor itself. And of course, you need to add if statement on top, but whatever. Now this is a work view. Of course, it's inside the editor. So let's close everything. And just the nodes outside the editor solution, we want to make sure that whenever we have Unity editor, for example, we use if Unity editor. Okay? And if. So this is okay. Initialization is okay. Update node is happening on runtime. Update node GUI. Okay? We want to cut it, paste it here, because it's editor stuff. There we go. Divide node, Unity editor. And this guy goes into update node inside the editor stuff. Here. And come on. There. Vector 2. That. Vector 3. that, Control Z, and if move it from here to here. Enums has nothing node base, and to find the node base usage, it's easy to do this. So it's inside our Unity editor, I hope. Yeah. Then draw connections, draw properties, draw help, draw status, and where is that one? Get node scheme. Control X, and more of these guys, of course. That process events is sitting, well, we have a redirect. Yeah, this guy too sits there. Context menu and callback, breaking connection and handling the connection and finalizing the connection. All of these are just Unity stuff, editorial stuff, sorry. Okay. So basically everything in node-based, other than the update node itself and the constructor and initialization actually, are sitting inside Unity editor. Good. Cool. And I can reset the flag because we now are sure that it's being deleted. Node graph. Deselect all nodes. Yeah, I just finalized this guy, so we just need to add that using if and an if on top. Node input has nothing to do with Unity editor. Node output has nothing to do with Unity editor. And we are done with our first iteration finally. So what is remained? Well, if you look, for example, I have an object reference not to set to an instance of object. Oh, an error. Node editor window line 33 and divide node 33. So divide node 33. Yeah. We should say if inputs dot 0 dot parent node equals to null, or inputs inputs 1 dot parent node equals to null, then simply return. That's because of that. And same thing has happened to an add node. So well, I had done this here. I can do it here and say if not inputs.any, then return. Okay, that should solve that. So clear, delete, clear, and add a divide. That was fortunate. Oh, we still have no reference. Line 37. Well, why? Oh yeah, I'm dumb. Or the parent node is equals null, or index 0, the parent node, equals to null. Those were the reasons for the null exception. And I think we are golden now. Clear? Yeah. Divide, delete, node, math, divide. If I add, I don't get that error because here we are looping for each. And instead of this, I want to be consistent in my code. So remove that part, Shift Tab, and then we say, well, instead of doing it that way, I will say for each inside inputs var input, if input dot parent node equals to null, then simply return. That would work. In here, we are checking the null simply. So we say we only need to say if inputs does not equal to null, or actually is equal to null, or not inputs dot any, then return. Okay, and that should get rid of those problems. And no null reference exception. Cool. So we are finished, guys. Really. But what is the problem here? In this first iteration, as I spoke inside my notes on theory, where was I? I had a phone call. Okay, the problem with this first iteration is that there is no special order in which the nodes are being compiled. For example, we added this guy, then this guy, then this guy. Okay, I add this guy there, I add this guy here. I connect it to here. And I connect guy here. I add another node here, one more node here. I connect this guy to here, this guy to here, and this guy to here. Now, which one is being calculated first? Because if I move them like this, and for example, special if I add a float node here, from here to here, then a float node from here to here, the more your nodes get busy, the less you remember the order. And right now I totally lost the order of nodes myself even. Okay, so which one will be evaluated first? We are simply in our close all but this close that one. In our node graph, when we are evaluating our graphs, we are simply going in a for each loop, and this for each loop will happen in the order that we added the nodes. So this node will be evaluated before this node, because I remember that I added this guy before this guy. So guess what? Before this node being evaluated, its sum will be 0, and it will just be the result of this guy. And for very short amount of time, it will jump up and down. It will have a hiccup. So this is bad, you know. Also, in case of our behavior trees, we would want to order these guys, because a behavior tree works like this. Let's say it's a start node. So in behavior tree case, we have a start node, okay? And we have a bunch of nodes below it, like this. And let's say this node is a sequencer. So the sequencer will work in order from left side toward right side, you know, like that. So right now we have no concept of ordering our nodes based on their left to right and top to bottom. So for example, I can hook it here, okay, or maybe hook it there and hook this guy there. So this is not how a behavior tree will behave. Behavior tree will go from this guy, from this top float, okay, toward the node below it first, and it accepts only one node from start to the first node. Then that node defines if it has multiple children and goes in order to children. So it will never jump from this node to this node. And we don't have any concept like that right now. Well, actually we don't have any real behavior tree right now, but there is no concept of doing something like that right now. So in the next iteration, the very first thing we want to do is that when we are evaluating a node, we will look at its children and see if it's evaluated or not. If it's not evaluated, we will look to evaluate it first. And if it's not evaluated, it's, for example, in this case, we'll look at its children. It says, okay, I'm evaluated. Then this guy will be evaluated. Then this guy will be evaluated. Then we move to the other node, and the whole process will become again. But this time, when we want its children, it says, ah, I'm evaluated. Okay, evaluate yourselves. This guy will say, are you evaluated? Yes, then I evaluate myself. But for that, I need a second node. Are you evaluated? Yes, then evaluate myself. Okay, so it's some sort of nested evaluation and recalling itself in base node. I have to do R&D on that before even thinking about recording a video. But, you know, oh, look at here. If I connect, it becomes occupied. Deconnect. Okay, it's easy. Easy fix, fast fix. When we are processing the events, it's here. Well, this is correct. Child node, if it's equal to null, then put this. But when I'm doing the handle connection, where is that guy? If the connection node is not null, then we check if its child equals null. If that's the case, we deselect this guy. And we are not setting that child to null anywhere. Interesting. Well, we want to remove this one from here. Don't want to make the output being unoccupied here, but here. Then we say connection node output. Well, we are doing it. Connect O. Okay. That was because I was in the middle of processing it. Now, there we go. Now it's behaving. Okay. Now if I break all the connections. Oh. See? It breaks the connection, although it keeps connecting to that guy. Okay, so yeah, that's another problem that we have, and I can't do it in first iteration. If an output here has more than one child, if I break the connection on the child, it makes this guy unoccupied, and basically outputs are tracking the inputs are tracking their output, but this node, when it's reading this node, it has no understanding if it has any more than one child, because take a look, node output child is only single child. Okay, so what we are doing when we are connecting this, for example, to this guy, we are losing these two nodes, and we are setting this guy as the child of this output node. So this output node will lose track of these two childs. The reason the network is still working is that the way we are reading the value from the input, and the input says, okay, I have this guy as output. But the output itself will keep just the last node that is connected as its child, not other ones. And that's one thing that we want to do in the next iteration. So we say to do make this a list for next iteration. Okay, and of course when we are doing that, when we do that, we need to go and, for example, when we are breaking the inputs, and when we are doing the child, not here, yeah, here, we should say to do make sure we don't have actually we should say remove child node from list, not setting it to null, because we are setting it to a list now. And here, do we have any child nodes? Yeah, here again we have to remove it from the list. Okay, and node inputs again has a parent node, but if we want an input to have more than one output, in case of dialog box, it can happen. For example, we have a dialog and two different things should be able to hit this guy. So again, we will to do change this to a list, and inside our base, when we are making the parent to null, we should say to do remove from list, and one more place, I think I have a parent node here, so that. Okay, and well, these were obvious places that I'm using these guys, but I am using it somewhere else. Parent node. So how should we take a look at here? Because we are finalizing the connection and we have a single node. Okay, so to do we will say find a way to utilize the list for parents and children if needed to. Okay, so right now we are resetting it to a single node because well, this guy has only one member, but when we have more than one member, we should find the member that we want to reset. Okay, that would be hard. Anyway, as you see, this first iteration was nice. We have node graphs, and well, the most time passed to find a proper way of drawing the graph, debugging that drawing, and of course breaking the connections. And you see that right now it only broke the connection to this guy because it knows that this is the last node that I connected. If I connect it to this guy, now this is the child node, and if I break the connection, it will only break the connection to the child node, so I have to come and break the connections myself manually. Okay, if I break the connections, for example here, it will remove that, but for the rest I have to go and do it manually. Okay, so yeah, we have a working network, but this network is not you know, flawless. It really is not flawless because, well, we have problems, as you see. And why not? Add it here, add it here. And we have a working network, but this network is not flawless. The first iteration's purpose was to find a way for first handling a graph, drawing the graph properly, and you know, the next iteration will be working on the things that we need to make this graph better and more professional. Also, as I think I mentioned it in previous episodes, but I have problem with moving this guy out of the view because simply my mouse is leaving this guy and there is no way to fix it. I tried it in many ways, but it's not being fixed. But yeah, the network is working. For example, if I add the float and make it 50, the whole node graph should work because now this guy is 150 added by 2050. Well, 50 by 50 is equals 100. 100 goes into this guy, it becomes 150. 150 with 100 equals 250, and then becomes 300. So it's working, but it's not flawless. Next iteration, we have to do stuff. First of all, we need to make it so that we can add more childs. Second of all, we need to find a way to evaluate this guy based on the order. Okay, so the thing that I am thinking about is that when I'm hitting this guy, becoming a list, the output becomes the list, I will first select those nodes that has no inputs. Those most of the time are nodes that evaluate themselves immediately. Then I will find their children, set their values, and I will set a flag and check if all the flags are okay now. Then I will check this guy to evaluate it. Then, for example, when I'm evaluating the next guy, well, there is no way to avoid nested ifs, nested callings actually, for evaluating these guys. But we will see what happens. We will see what will work. And I hope we can work around these guys and have a nice graph node in next iteration. But this by itself, well, guess what? In design time, we will have hiccups, okay? But if the math is the only thing we are doing, in runtime, we will be okay. So until next episode, have fun everyone. Bye-bye.